It's your boy, Mr. Sav.
Hey guys, it's Mr. Savarese. Happy Tuesday. It's Tuesday, March 24th. We got a whole new lesson today. Thank you for doing the homework. If you did the homework, if you didn't do the homework, hop to it. Go do the homework, please. Some of you did not. I don't know what you're expecting. Do the homework. There will be homework today as well. There is a video today. It ended up being longer than yesterday. Still not a full class period though, so I think we're good. I heard some really constructive comments yesterday about the video, so I made the paper straight. I know a bunch of people were not happy about it being sideways. And what was the other thing that I did? Oh, I figured out how to like edit multiple camera angles, so you're gonna see some cool tricks today. So please make sure that you leave a comment underneath with your name. That will be your attendance for today, and we'll try to do that every day. And please tell people that if they did not do that yesterday that they have to, please. Cool. So today we're going to talk about scientific notation, which I know we've talked about before. It's where we left off in actual physical school. And this will be the last thing that we review in chapter 6. And then we're going to start reviewing the other stuff. We're going to go back to chapter 1, talk about what types of numbers there are. But let's finish out chapter 6. All right. So let's have a look at the homework. First up, 2x cubed times 2x squared. We're going to be multiplying the coefficients. 2 times 2 is 4. X cubed times x squared. We're going to add those, so we get x to the 5th power. Our final answer should be 4x to the 5th power. Our second example here, y to the negative 7th. Well, the first thing we're going to do is say, we don't like that negative exponent. We're going to find a fake reciprocal. So 1 over y to the positive 7th, and that's as far as we can go. Our next example here, 52x to the 6th over 13x to the negative 7th. Well, 52 and 13 are divisible by each other. So 52 divided by 13, that's going to give us 4. X to the 6th divided by x to the negative 7th. 6 minus negative 7 is really 6 plus 7, which is 13. So we get 4x to the 13th power. Let me look down here. 6x to the 7th divided by 2x to the 4th. 6 divided by 2 is 3. x7 divided by x4 gives us x to the 3rd power. Done. Then we're going to look here. This is where things get a little more interesting, a little more spicy. So here we have 5 and 20. That's divisible, so we're going to say this is 1 and this is 4. Then we could say that the numerator is now going to be x squared and then y to the negative 4th power, and this is all in parentheses with a 4th exponent. Now the reason we have y to the 4th is because this is an implied 1. 1 minus 5 is negative 4, and we put that up here. Our next step would be to get rid of this parentheses situation. So we're going to distribute the 4th power. 1 to the 4th power is 1, x to the 8th, y to the negative 16th power, and then 4 to the 4th power, we can't forget that, is 256. Then we want to simplify this one more time because we have this negative exponent. We're going to say that this is x to the 8th power over 256, y to the 16th power. Then let's have a look at number 6. Number 6, 3 and 12 are divisible. We're going to say that that is 1, 2, and 6. 2 minus 6 is negative 4, so x to the negative 4th, y to the negative 6th over 4. We don't like these negatives, so we're going to say that this is 1 over 4x to the 4th, y to the 6th. So that's our first column from the homework. Number 7, I gave you an easy one just to follow up. 5 minus 1, really. So we get x to the 4th power. Here, it becomes a little more challenging. We're going to say that this is 2c d to the 4th power squared times c d to the 5th power. The first thing we want to do is get rid of those parentheses. So we're going to be distributing, and I use that word kind of loosely. It's not really the word we want to use here, but we're going to be distributing the exponent here. So we're going to say that this is 4c squared d to the 8th power. We multiply, this is implied 1. 2 squared is 4, c 1 times 2 is 2, 4 times 2 is 8, and here it's going to be c to the 5th, d to the 5th. Now we're not finished when we say that because these can be simplified further. So 4 times 1 is an implied 1 here. 4 times 1 is 4, 2 plus 5 is 7, and 8 plus 5 is 13. So it's 4c to the 7th, d to the 13th. Number 9, similar idea. We want to multiply our coefficients and then find all the pieces that match. So x's and y's, they match, so they go together. So we're going to say here for number 9, this becomes 10x to the 6th, y to the negative 2nd power. We don't like our negative exponent, so we're going to say that this is, as a final answer, 10x to the 6th over y to the 2nd power. Number 10, the same idea with the 3rd power. We're going to say 3 times 3 times 3. Well, that's 3 times 3 is 9, times 3 is 27. S to the 3rd power is s to the 1st, implied 1. 1 times 3 is 3. And then 12 times 3 is 36. That's t to the 36th power. Number 11 is one of the more challenging ones that you will probably see. And the thing to note here is that there are many things happening, but the important piece to pay attention to is the negative 4th exponent here. We don't like it. We want to get rid of it as soon as we possibly can. So a good idea would be, as a first step, get rid of that negative by taking the entire fraction and just flipping it. This is a true reciprocal situation. So we're going to take this and flip it that way. So when we do that, we don't need to change any of the exponents inside because we're changing the exponent outside. And that's going to make it much easier. If we took this and gave, okay, negative 8, negative 12, that'll still be 0. When we had all those negative exponents in the numerator, we'd have to bring them down anyway. So we're saving ourselves a step by flipping this first, and this becomes positive. Then we distribute the positive, and it's like we'd spent all that time doing it the longer way. So we're going to take this, and we're going to say that this is 3a to the 3rd power, b to the 4th power, c to the 3rd power, over the numerator, negative 7a to the 2nd power, b to the 3rd power, c to the 0 power. And this is all now to the 4th power as a positive number. We can then start to simplify. 3 and 2 becomes 1. So this is going to be 3a to the 1st, b to the 1st, c to the 3rd, over negative 7, still raised to the power of 4. So we still have work to do, but it's much simpler than if we'd done anything else. Our next step, we're going to put each of these to the 4th power. So we're going to have 3 to the 4th power, a to the 4th power, b to the 4th power, and c to the 3 times 4, 12th power. Then down here, we're going to have negative 7 to the 4th power. In the end, what this gets us as our final result will be 81, a to the 4th, b to the 4th, c to the 12th, over 2,401. And again, this is a positive 2,401 because even though this number is negative, it has an even exponent, and even exponents will always give us a positive result. So now we're going to be talking about scientific notation, which is something we've talked about before, but it's worth going over. It always is useful. So the first thing we're going to look at here, of course, is our definitions for the parts of scientific notation. Our first part here, 4.56, that's going to be called our multiplier. Our second part here is going to be called our base 10. So our multiplier is always between the numbers 1 and 10. That's very important. If we were to write that as an inequality, we would say that 1 is less than or equal to x, but x is less than 10, meaning that x could be 1, but x cannot be 10, and it could be any of the numbers in between for sure. So when we have standard notation, we want to make sure that our positive exponents, we're going to take it from scientific to standard. The positive is going to bring us to the right. But a negative exponent, which represents the small numbers, those are going to move to the left. So for example, 4.56 times 10 to the 7th, our number from up here, if we were to take that and put it into standard notation, we would move 7 units to the right because it's a positive 7. Now there are already 2 units that are filled, so we're going to have 4, 5, 6, and 2 of them are done, so we have 5 more. So 1, 2, 3, 4, 5. So our finished number, 1, 2, 3, 1, 2, 3, is 45,600,000. If we continue to this number, we have a negative exponent, which means we're going to be moving to the left. And since there's 1 space already filled with a number, we're going to have 5 spaces to go. So that means we're going to have 1, 2, 3, 4, 5, 9, 8, 7 as our digits. Now it's interesting to note that both of these end up having 5 additional blank spaces, unit places to have, but neither of the exponents was the number 5. And that's very important to remember that if you follow the rules, sometimes you get weird results. All right, let's look at part 2 here. Operations. So we have the operations in scientific notation. We always want to be following our exponent rules. There's a reason we learn those first, so that we can apply them with scientific notation. So when we add and subtract our scientific notation numbers, well, we have to make sure that we are adding the multipliers, but our first step is to make sure that the base 10s are the same. And right here, they're not. So the first step we should take is to make them equal to each other. We're going to do that by saying 3.45 times 10 to the 6th. Well, it can stay as it is. But 4.56 times 10 to the 7th, we don't want that to be 10 to the 7th. We want it to be 10 to the 6th. So this number here has to change. Now the 7 meant that we were going to go 7 spaces to the right, but we only want it to be 6. So it means we have to do 1 already. So this is going to be 0.60, and the number in front of it is 45. So we get 45.60 times 10 to the 6th as our new number. Since these base 10s match just like when fractions, the denominators have to match, here we have base 10s that have to match. So 10 to the 6th and 10 to the 6th, it's going to end up with another 10 to the 6th. If it had to match, it has to stay matching. If they had to be the same, they have to stay the same. Now for a multiplier, when we add these together, we're going to say this is 5, that carries, this is 3 plus 1 is 4, plus 5 is 9. We have 49.05 times 10 to the 6th, and that's fine, that's a number, but it's not scientific notation. So we're going to take one more step, and we're going to say this is 4.905 times 10 to the 7th power, and that is our final answer for that. Multiplication and division is actually even slightly easier because nothing has to match. All we have to do is multiply our multipliers and add our exponents. So let's do the exponent part first. We get 10 to the 13th and 10 to the 3rd. That's going to give us times 10 to the 16th. 13 plus 3 is 16. But then we have to say, well, 2.1 times 9.8, that's 20.58, which is nice, but we have to change it. So 2.058 times 10 to the 17th power is going to be our result here. All right, so let's look at the division down here. Now, the same process applies, just obviously following those exponent rules. So 5.2 times 10 to the 46th divided by 4 times 10 to the 12th. First thing we're going to do is work with our base 10s. 10 to the 46th and 10 to the 12th is going to give us 10 to the 34th. And when we subtract, and 5.2 divided by 4, well, that's going to give us 1.3, and we don't need to change that. That's already in scientific notation. All right, so let's look at some examples using the calculator. Using the calculator. So when we add or subtract using the calculator, we have, for example, this. Well, that's fine, but we need to, when we use the calculator, use the E key. That's going to be incredibly important for us. And when we use that key, that tells us the times 10 and it raises that number to an exponent. So we could rewrite this, and we're always going to use parentheses, as parentheses 5e negative 5 plus parentheses 2.46e negative 3. Now let's type that into a calculator and see what we get. Did I take this from work? Definitely I did. Was I supposed to? I have no idea. So parentheses 5e negative 5, close parentheses. Can you see that? There it is. Then we're going to say plus parentheses 2.46e, what was it? Negative 3. Okay, did I type that incorrectly? Yes, I did. Press enter, and we get that, which is notably not scientific notation. So let's copy that down. So 0.00251, And to put that into scientific notation, we're going to put the decimal point between the 2 and the 5. So that's going to be 2.51 times 10 to the, what would that be? 1, 2, 3. 10 to the negative third power. Now if we multiply and divide, very similar. I've done that for us here already. We're dividing, we're using the E key, so that's what we're going to type in. This 10 to the 7th gets collapsed into the letter E. So let's type that in. Parentheses first, always, always, always. 3.6 E7 divided by, can you see that on the screen? There it is, 3.6 E7 divided by, parentheses, 7.2 E4. We press enter and we get 500, which again is not scientific notation. If the number fits on the screen, the calculator doesn't bother to put it in scientific notation. So when we get 500, very simple to convert, we get 5 times 10 to the second power. All right, so let's look at some word problems here. Our first word problem: how many times greater is the thickness of a dime than the thickness of a dollar bill? Well, the first thing we want to notice is that the thickness of a dime is given in standard notation, and the thickness of a dollar bill is given in scientific notation. So we want to convert them both to scientific notation. So the thickness of this we're going to say is 1.35 times 10 to the negative first power. And they're both in centimeters, so we don't need to worry about that. Then it says how many times greater is the dime than the dollar? So what we should be doing is dividing. So we're going to say this is 1.35 times 10 to the negative first divided by 1.0922 times 10 to the negative second. My handwriting does not look nice on this. Well, you get the idea. So when we divide this, we're going to use the calculator. Let's type that in using E. So parentheses 1.35 E negative 1 divided by 1.0922 E negative 2. And we get 12.36. Now, did I type that in correctly? You know me, I always double check. Negative first, I should double check before, and negative second. Yep, so we get 12.36-ish. There's a 0 after the 6, so we can leave it at that. And what that means for us is not 12.36 centimeters. What that means for us is that the dime is 12.36 times thicker than the dollar bill. So if we were to write an answer to this in an exam, we would say the dime is 12.36 times thicker than the dollar. You get the idea. My handwriting is really not nice in this. All right, let's look at another word problem. So we're given the area here, and we're told this is the length of one side. And I guess I didn't put the problem here, but the problem would be, what is the perimeter of this shape? So we look for perimeter. We don't know what it is. So in order to find the other length, which we don't know, we're going to take the area, and we're going to divide area by one of the lengths. So we're going to say this is 5.612 times 10 to the 14th power divided by 9.2 times 10 to the 7th power. And again, that is something that we can type directly into our calculator, and we don't need to do much of anything with that by hand. So we're going to type 5, that's a 4. 5.612 E14 divided by 9.2 E7, and we get 6, 1, and then 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. Well, in scientific notation, that's 6.1 times 10 to the 5 zeros plus 1 is 6. That's times 10 to the 6th. Now they ask us for the perimeter, which means that we need to be adding all four sides of this together. So if this is the height, and this other number we were given is the width, that means that we have to say this number twice, and this number twice, and then find the sum. So let's do that using the calculator. We can put in parentheses, 2 parentheses, you see that there? Yep. 2 parentheses, 9.2 E7, close parentheses, plus 2, parentheses, 6.1e6. And we type that in, we get this disgusting number, but that is our perimeter. So our perimeter number, we'll write that down, is 1962, and then 1, 2, 3, 4, 5 zeros. And in scientific notation, that's 1.962, and 5 plus 3 is 8. So that's times 10 to the 8th power, and the unit is centimeters. Let's look at one more problem, and then we will be done with this lesson for today. So we're told that the diameter of the sun is 1,400,000 kilometers, and the diameter of Earth is 1.28 times 10 to the 4th kilometers. What are we going to do with that information? We're going to find how many times larger is the sun than the Earth. The first thing we need to do is put this number in scientific notation. So that's 1.4 times 10 to the 6 kilometers. And then how many times larger? Well, whenever we're asked how many times larger something is, we always want to perform division. So that's what we're going to do now. So 1.4 times 10 to the 6th divided by 1.28 times 10 to the 4th. And you can tell we're doing this correctly because we know the sun is larger than the Earth, and this exponent of 6 is larger than that exponent of 4. Even if they were the same, the 1.4 is greater than the 1.2, but the sun is so much bigger than the Earth that the exponent itself is different, which means it's many orders of magnitude larger. So when we divide this, let's do this quickly. 1.4e6 divided by 1.28 e4, and we get 109.375. So 109 and 3/8, it appears, 109.375. So that means that the sun is 109.375 times larger. All right, so that's where we're going to stop for today with our word problems. We're done. So that's it for today. Let me know if there's anything that you would like to go over. Please remember to join the GoToMeeting links that are on Classroom if you have any questions. That's what those meetings are for. Please take advantage of that. I only saw around 20 to 25 people yesterday, which is still good, but there are at least 90 of you, so please make sure that you're taking advantage of that if you have any questions. You can type them, you can ask them out loud, you don't need to have a camera on. I know what you look like, so please give that a shot if you are at all confused about what we're doing. Okay, I will see you guys, there won't be a video tomorrow, I will see you guys in 2 days. All right, have a good night, be well.